Okay, I can't get this one to play, so we'll just do it from the frozen position. Given the polynomial p of x equals x to the fourth minus 2x cubed minus 8x plus 16. Bad news. That sucker is not factored. We are going to have to factor it ourselves. Find the sketch of the polynomial with all intercepts and proper end behavior. Okay, solution must factor first. Well, the good news is there's no common factor among all four of those terms, so we don't have to pull out a greatest common factor. Now we count the number of terms. Remember, terms are added and subtracted basically together. 1, 2, 3, 4 terms, so we're going to try factor by grouping. Out of the first group of x to the fourth minus 2x cubed, we pull out a common factor of x to the third power. It leaves parenthesis x and then minus 2. Out of the group of the second two terms, negative 8x plus 16, we'll try a negative 8. If that doesn't work, we'll try a positive 8. So let's try the negative 8 common factor. It leaves parenthesis x and then minus 2, because a negative 8 times a negative 2 is a positive 16. So the miracle has occurred. We have our big miracle factor in parenthesis x minus 2. Bring that out to the front. Multiply that by parenthesis. What remains when we strip the x minus 2 away from the first piece, it leaves x cubed. Strip it away from the second piece, it leaves negative 8. This is x minus 2 times x cubed minus 2 cubed. So we're not finished factoring. We can use the formula for the difference between cubes to continue factoring. So bring down the x minus 2 and then work on the x cubed minus 2 cubed. It's equal to short parenthesis times long parenthesis. X minus 2 times parenthesis x to the second power plus x times 2, which is 2x, plus 2 to the second power, which is 4. So writing this in exponential form, I have parenthesis x minus 2 parenthesis squared times parenthesis x squared plus 2x plus 4 for the complete factorization of our polynomial. Remember, the second degree factor, the last factor that has x to the second power, it's prime because we use the formula for the difference between two cubes, so you cannot factor that any further. Okay, what is the degree of this polynomial? Well, if I continue distributing the multiplication, I would end up with an x to the fourth, so it's an even degree. And what is the lead coefficient? I would end up with the x to the fourth power being multiplied by the coefficient 1, which is a positive number, and that indicates the left is moving upward and the right side will be moving upward in this graph. Now the roots, the zeros, are going to be listed here with their multiplicity, whether their x-intercept is a cross or a kiss, in the list of the x-intercept. There's only one root here. There's only one real root. It's in the first factor, x minus 2. The number being subtracted is 2. What is the multiplicity of this root 2? It is the power on the outside of x minus 2. It's also 2. So the multiplicity is an even number, which indicates the x-intercept is a kiss. It's just going to touch and turn around back where it came from. The x-intercept itself is the ordered pair xy equals the root, the 0, 2, comma, 0. Now, we didn't talk about what happens with the second factor, x squared plus 2x plus 4. We'll talk about that in a moment. The y-intercept, we can find that by evaluating the function p at x equals 0, which will give us 4 times 4, which is 16. So the ordered pair 0, 16 is the y-intercept. So now we'll talk about the irreducible second degree factor x squared plus 2x plus 4. That guy came from the formula, and it does not factor. It's irreducible. So to find out what the roots are there, we would use the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4 times a times c over 2 times a. We'll simplify that mess and we'll get x equals negative 2 plus or minus the square root of negative 12 over 2. Oh, put on the brakes. The square root of negative? That is not real. That represents imaginary roots, and we're graphing on the real axis, x and y axis. We cannot include imaginary roots in our graph, so just ignore those. Okay, no contribution there. Now let's do the sketch. Let's do our y-axis and our x-axis. Identify, locate, and graph the x-intercept at the root 2, the y-intercept at 16 on the y-axis. Remember that on both sides of this intercept 2, we are going to be positive because we need the endpoints to go up on both sides. So we have the graph that you see in the final box of our polynomial.